Imagine looking up at the night sky, a vast, dark canvas sprinkled with stars. For millennia, this view has inspired dreams of exploration and discovery. But what if that frontier, the final frontier, was about to close forever? What if we, through our own actions, were building a cage around our world, trapping humanity on Earth for centuries to come? This isn't the plot of a science fiction movie, it's a terrifyingly real possibility known as the Kessler Syndrome. Since the dawn of the space age, we've been launching things into orbit. Satellites for communication, for weather forecasting, for GPS, for scientific research. We've sent probes to distant planets and telescopes to peer into the universe's past. Each launch, each mission, has left something behind. Spent rocket stages, defunct satellites, fragments from accidental explosions, even a lost glove from an astronaut. This is space junk, or orbital debris, and there's a lot of it. Think of it as a cloud of cosmic shrapnel enveloping our planet. Millions of pieces, from the size of a school bus down to a fleck of paint, are hurtling around Earth at incredible speeds. We're talking about velocities upwards of 17,500 miles per hour, or nearly 28,000 kilometers per hour. At those speeds, even a tiny object carries an enormous amount of kinetic energy. A paint chip can hit with the force of a bowling ball. A small screw could disable a multi-million-dollar satellite. This isn't just a hypothetical problem. The International Space Station has had to perform emergency maneuvers numerous times to dodge incoming debris. Astronauts have found pits and craters on spacecraft windows caused by impacts from minuscule, untrackable objects. For now, these are isolated incidents, manageable risks in the dangerous business of space exploration. But what happens when this cloud of debris gets too dense? That's where Donald J. Kessler, a NASA scientist, comes in. In 1978, Kessler proposed a chilling scenario. He realized that as the amount of debris in orbit increases, the probability of collisions between objects also increases. Here's the terrifying part: when two objects collide in space, they don't just stop. They shatter into thousands of smaller pieces of debris. Each of those new fragments becomes another high-speed bullet, dramatically increasing the chance of further collisions. This is the heart of the Kessler Syndrome, or runaway chain reaction. One collision creates debris that causes more collisions, which in turn creates even more debris. It's a cascade effect, an exponential growth of junk. The process would start slowly, but once it reaches a critical tipping point, it would become self-sustaining and unstoppable. The debris cloud would grow thicker and thicker, until low Earth orbit becomes a lethal minefield. Any new satellite launched into this environment would have a very short lifespan before being shredded by the storm of shrapnel. The services we rely on every day would start to fail. GPS navigation would become unreliable, stranding planes, ships, and cars. Global communication systems would break down, disrupting everything from international finance to your ability to call a loved one overseas. Weather forecasting would become a guessing game, leaving us vulnerable to hurricanes and other natural disasters. Scientific research from space-based observatories would cease, blinding us to cosmic events and changes in our own planet's climate. But the most profound consequence of the Kessler Syndrome would be this: it would make space travel through low Earth orbit nearly impossible. The risk of a catastrophic impact on any crewed or uncrewed mission would be too high to justify. We would have effectively built a wall around our own planet. The gate to the solar system, and to the stars beyond, would slam shut. Humanity would be trapped on Earth, potentially for generations, or even centuries, until the debris cloud naturally deorbits through atmospheric drag, a process that takes an incredibly long time. Are we there yet? Not quite, but many experts believe we are getting dangerously close to the tipping point. The number of satellites being launched is increasing exponentially, with plans for massive megaconstellations that will add tens of thousands of new objects to an already crowded environment. In 2007, China conducted an anti-satellite missile test, destroying one of its own weather satellites. That single event created over 3,000 pieces of trackable debris and likely hundreds of thousands of smaller, untrackable fragments. It was one of the worst debris-generating events in history. Then, in 2009, an active American communications satellite, Iridium-33, collided with a defunct Russian military satellite, Cosmos 2251. This was the first major collision between two intact satellites. The impact instantly created two new clouds of debris, adding nearly 2,000 large pieces to the orbital junkyard. These events were stark warnings. They demonstrated that the Kessler Syndrome is not just a theory. The chain reaction is possible. So, what can we do? The situation seems dire, but there is hope. Space agencies and private companies around the world are working on solutions. These range from better tracking of existing debris to developing new technologies for its removal. Ideas include giant nets to capture junk, harpoons to spear defunct satellites, and even lasers to nudge debris into a lower orbit where it will burn up in the atmosphere. International guidelines are also being established for end-of-life disposal of satellites, requiring operators to ensure their spacecraft can be safely deorbited within 25 years of mission completion. But these are just guidelines, and not always followed. The challenge is immense. It's like trying to clean up a toxic spill that spans the entire globe and is moving at hypersonic speeds. The legal and political hurdles are just as significant as the technical ones. Who is responsible for cleaning up the mess? Who pays for it? The future of humanity as a spacefaring species hangs in the balance. Our dreams of colonizing Mars, of mining asteroids, of exploring other star systems, all of them depend on keeping our front doorstep, low Earth orbit, clear and safe. We are at a critical juncture. The decisions we make today, the technologies we develop, and the international cooperation we can foster will determine whether the sky remains a gateway to infinite possibility or becomes the ceiling of our planetary prison. The next time you look up at the stars, remember the invisible cloud that surrounds us. It's a testament to our ingenuity, but also a stark reminder of our responsibility. We must act now to clean up our cosmic backyard, before the Kessler Syndrome becomes a reality and we find ourselves trapped on Earth, forever gazing at a sky we can no longer reach. If you found this journey into the perils of space junk fascinating and want to explore more about the cosmos and our place in it, be sure to subscribe to my channel, Space Repo. We have a universe of topics to discover together.